Hi everybody. In this video we're going to look at the area of a sector of a circle. So first of all, let's draw a circle so you can see what we're talking about here. Guess we'll use that one. Oh, that's kind of hard to see. Let's change that. So there is a formula that we're going to use, but really the idea behind the formula is it's just the portion of, so here, first of all, let's see what a sector is. So here's the center of a circle, let's call it C. And a sector is kind of like this, you can think of it as like a pizza slice. So it's a slice is like a sector. Okay. But formally, the definition is if you have two radii with an intersected arc in between. That's an arc there. So this shaded region is a sector. So you have two radii bounded on either side, and you have an arc length S. So that's a sector. I kind of think like it's a pizza pie, because you can have lots of sectors on a circle. So if we're given a specific circle with, let's say, C as the center and 10 centimeters as our radius, so R is 10 centimeters, and we're given the measure of the arc length AB. So we're given the measure of arc length AB, which is 78 degrees, which we know the central angle of the circle, angle ACB, is also 78 degrees if it's located in the center of the circle. So we just use this general formula. The area of the sector is just going to be n over 360, kind of like the arc length formula, times pi r squared. And note that pi r squared, that's just the area formula for a circle. That's just the area of a circle formula. And we've seen that before. Okay, so basically the yellow part of this equation is the portion of the circle given by the 360 degrees is the degrees around the whole circle, and our sector arc length is 78 degrees. So we just got to plug in those values. So area of the sector is 78 over 360 degrees times pi. R from this problem was 10 r squared. All right, so we can just do some algebra here. We're gonna get 78 over 360 times 100 pi. And we can do some cross canceling here. Let's see, we can divide that by 4 to get 25. Divide that by 4 to get 90. We can cross cancel. That's divisible by 5. That's divisible by 5. So it's going to be 5 left over. 90 divided by 5. 18. Okay, so let's rewrite this now. So far we have 78 times 5, and pi is still on top, over 18. 78 is divisible by 3. You can divide 78 by 3 and you can get 26. 18 is divisible by 3 and you get 6. And we can simplify this one more time. So let's use another color here. This is a good problem because it has simplification in there. 26 is even, 6 is even, so that can go down to 13, and that can go down to 3. So on the bottom we just have 3 left over. Let's go to another slide and clean this up a little bit. So we have 13 on the top, 5 pi on the top, and on the bottom we had that lonely 3 down there, and we can't cross cancel anything else there. So we can write this as 13 times 5, well that's going to be 65 pi over 3. However, remember we want the area of the circle, and we had units of centimeters, so we're going to do centimeters squared. So our answer is centimeters squared, 65 pi over 3 centimeters squared. Remember, when you deal with area, you have to have 2-dimensional units. So remember, area has the square units. Volume is cubic units, and like circumference is your 1-dimensional units like feet, inches, miles, that kind of thing. All right, well that's all we're going to do here for this video, and stay tuned for the next video when we find the area of a segment of a circle.